Welcome to Chapter 28, Oligopoly. Oligopoly is a market with a few competitors, each of which has an effect on market prices. We've considered so far in this course the two polar opposites. We've considered the perfectly competitive market where there were a large number of buyers and sellers, each of which were too small to affect the marketplace. Then we considered monopoly, where there was one firm that supplied the entire marketplace. Oligopoly is the interesting middle case, where you have a few competitors. And one informal way to think about few, there are few enough competitors that each competitor is aware of what the other competitors are doing, right? So there's countably few. And when we consider how to analyze this market and how to set it up, as always, Varian helpfully makes the simplifying assumptions to make the math as easy as possible. Few could be as few as two. So to simplify the mathematics of oligopoly, Hal will assume two firms, a homogeneous product in two firms. And the terminology for this is he will assume a duopoly. We have four variations of duopoly that Varian considers in Chapter 28. One dimension of choice is whether the firms move at the same time or simultaneously, or do they move in sequence, where one moves first, the other firm sees what the first firm did, and then they respond to it. And then you get this back and forth between the two firms. The other dimension of choice that we can consider is whether the firms choose the output level to produce, or do they choose the price to charge for the output that they produce. And then we get in the four cells the four variations of it. We will consider first a Cournot duopoly. So from the matrix, you can see a Cournot duopoly is where we have two firms that move simultaneously, meaning each firm cannot see what their competitor does when they make their choice, and the choice variable is how much output to produce. Okay. So to compute equilibrium in this type of market, each firm chooses its output level where marginal revenue is equal to marginal cost as before, but now marginal revenue is going to be just a little bit more complex. Marginal revenue, which remember is the revenue the firm gets from selling one more unit of output, now depends upon both the output that the firm itself makes and the output that its competitor chooses to produce. Now, if both firms move simultaneously, neither firm knows for sure what the other firm will choose. So, the way we define equilibrium in this market is when each firm produces what its competitor anticipated it to produce. So the first step in computing equilibrium in a Cournot duopoly is computing this thing that Varian defines as the reaction function. So in other words, the reaction defines one firm's output as a reaction to what it thinks its competitor is going to do. So to flesh this out, remember, firm 1 will set firm 1's marginal revenue equal to firm 1's marginal cost. So inverse demand in this type of market, the price is equal to some vertical intercept minus the quantity that firm 1 produces minus the quantity that firm 2 produces. So the total revenue for firm 1 would be the price times the output that firm 1 chooses to produce. And then we substitute in the inverse demand function from the previous line up, and we get total revenue now as a function of the quantity that firm 1 produces and the quantity that firm 2 produces. we differentiate firm 1's total revenue with respect to firm 1's output to get firm 1's marginal revenue. So you'll notice that firm 1's marginal revenue is a function, again, its own output and the output of its competitor. We'll set firm 1's marginal revenue equal to firm 1's marginal cost. And in this particular numeric example, I'm going to assume that the marginal cost is equal to 10. So when we set firm 1's marginal revenue equal to firm 1's marginal cost, that defines firm 1's output. So when we make this equality, what we'll do is we'll rearrange the math to put firm 1's output on the left-hand side, because setting firm 1's marginal revenue equal to firm 1's marginal cost defines firm 1's output. This output, you'll see one line up from the bottom of the column to my left, Q1 is equal to 45 minus 0.5 Q2. And this is firm 1's reaction function. So following variance notation, R sub 1 says this is how firm 1 reacts to the output that they believe firm 2 is going to produce. They will produce 45 minus Q2 over 2. For firm 2, we will do the exact same thing. The inverse demand is, of course, shared between firm 1 and firm 2, but now firm 2's total revenue is price times the output that firm 2 chooses. Get total revenue as a function of firm 1's output and firm 2's output. We differentiate with respect to firm 2's output to get marginal revenue. For firm 2, we set that equal to firm 2's marginal cost, and then setting firm 2's marginal revenue equal to firm 2's marginal cost defines firm 2's output. And then that gives me a reaction function. Now notice that the reaction functions are actually symmetric. And the reason why in this particular case is that firm 1 and firm 2's marginal costs are the same. I went through all the math in great detail because you would have to do this if firm 1 and firm 2's marginal costs were different. But if firm 1 and firm 2 share the same marginal cost, you will have symmetric reaction functions. And perhaps it's bad form of me to tell you this, but you can just solve once and then swap Q1 for Q2 and you'll be just fine. So to get equilibrium, what I could do is substitute one reaction function into the other. So this notation I have R1 in the bottom line, R1 open parentheses of R2 open parentheses Q1 close close. What that says is firm 1's output as a reaction to how firm 2 reacts to what firm 1 does. And the way I operationalize that is I took the firm 1 reaction function and substituted the firm 2 reaction function in for Q2. Okay. So now I have a single equation with a single unknown variable Q1, and I can just do simple algebra, rearrange it, and solve for Q1. So firm 1 is going to produce 30 units of output. I can then, of course, put that 30 units of output that firm 1 chooses into firm 2's reaction function and find that firm 2 also produces 30 units of output. Okay? And this was, of course, because their two reaction functions were the same. I could solve it graphically. I could plot the firm 1 reaction function and the firm 2 reaction function, and you can see where the two reaction functions intersect. That's where the equilibrium occurs. But if so, artwork is not my forte. This is why I love typeset slides so much, because I don't have to draw things. So if you draw pictures like I draw pictures, the math is wonderful, right? You can get precise answers quickly, but the graphic provides useful intuition. Okay, so there we have it. A Stackelberg market was the market where both firm 1 and firm 2 choose output levels, but later. So they move in, the firms move in sequence. If they move in sequence, the firm that gets to move first is defined as the leader. So the leader moves first, the follower moves next. Now, a profit maximizing leader is going to anticipate how the follower will react, and they set their leader's output accordingly, knowing how the follower firm will react to them. So in this case, the way we could find equilibrium is we solve by backward induction, meaning we start at the end of the problem and work backwards toward the beginning. So if we're starting at the end and going backwards, we solve the follower's choice problem first. Now, thinking of one kind of interesting example of this, back in the 1980s, when the PC era was really building steam and getting going, there were two major producers of CPU chips, Intel and AMD. And in the very early days, AMD had this incredibly interesting business model where basically what they would do is they would wait until Intel came out with a new CPU chip, and then they had this incredibly clever way of cloning it. So roughly 3 to 6 months after Intel would introduce a new processor, AMD would introduce a clone of it. Okay. So basically the choice was then Intel being the leader, they moved first, so they would sell the number of chips that they would desire. AMD, the follower firm, could see AMD, the follower firm could see how many chips Intel was making, and then they made their choice. So, if we want to solve this as a conventional Stackelberg equilibrium, we have to solve it with backward induction with the follower firm first. So let this be, so we have, of course, as before, the conventional inverse demand curve. So I've assumed a very simple one, 100 minus the quantity that each firm produces. The total revenue of the follower firm, just like before, is the price that's shared between the two of them times the quantity that the follower firm, AMD, produces. And then we get the total revenue of the follower firm. We differentiate that with respect to the follower firm's output and get the follower's marginal revenue. Set marginal revenue equal to marginal cost. So if we do that for the follower firm, that defines the follower firm's output level. And then we get a reaction function for the follower firm. Now, the leader firm is going to do something just a little bit different. So the leader firm, the inverse demand curve is 100 minus the quantity the follower firm produces minus the quantity that the leader firm chooses to produce, but the leader firm knows how the follower firm will react to its choice. So what we do is in the inverse demand function, we substitute in the follower firm's reaction function. So this incorporates the information of how is it the follower firm is going to respond to the choice that the leader firm makes. So we put that in, we can simplify it, and now we have this inverse demand curve for the leader firm, which incorporates the information of how the follower firm responds. So we can compute total revenue for the leader firm, differentiate to get marginal revenue. We set the leader's marginal revenue to the leader's marginal cost, and we get the quantity that the leader will produce. If we take that quantity of 45, which the leader firm will announce, we substitute that into the follower firm's reaction function. The follower firm is going to respond to the leader's choice of 5 and produce 22.5. Okay, so the privilege of being the leader is by moving first, they can grab a larger portion of the market. So it's good to be the leader. The price leadership model, this would be where the two firms move in sequence, and rather than set quantity as we did in the previous example, the firms move in sequence, but they set price. And hence, we call it the price leadership model. So there is a dominant firm, the leader, and usually the way that a firm can become the leader firm is that they have a lower marginal cost of production. They're larger, they're more efficient. That gives them the privilege of setting the price first. And the competitors, the follower firms, basically are price takers, right? They more or less have to live with the price that the leader firm establishes. So what the leader's problem is, the leader gets to move first. The leader also understands how it is the follower firms are going to respond to the price they announce. So what the leader firm does is they subtract from market demand what the competitors will supply. Okay, so so much like the Stackelberg example, the leader will determine what market they own after the follower firms respond. And what we call this is residual demand. So as the words would suggest, residual demand is what's left over to the leader firm after the follower firms respond to the choice the leader makes. In this residual market, the residual market is the market that's owned by the leader firm, so the leader can basically behave as a profit-maximizing monopolist within the residual market. Now, an example of the price leadership model, I had to take my chance to show you more car pictures. General Motors in the 1950s was incredibly dominant within the American car market. At its high point, General Motors had 50% of the American car market all to itself. So they had lower costs, and General Motors, being the price leader, had the ability to basically set the prices of new cars. And then roughly 4 or 5 days later, their competitors, Ford, Chrysler, and the various independents, would announce their prices in response to what General Motors set. So the car, I guess I have to talk about this a little bit. The 1959 Cadillac Eldorado. This was basically the king of the tail fins. So starting with the 1949 Cadillac, it introduced the tail fins to the American public. And tail fins grew all through the 1950s. The car with absolute largest tail fins was the 59 Caddy. And the tail fins were an astonishing 16 inches. So I wanted to be sure and give you, to my immediate left, the picture, the back view of the tail fins, so you could appreciate their beauty and how big they are, right? So GM had the ability to set prices because of their dominant position. So here's how it works. the supply of all the competitor firms put together. So, I've chosen an extremely simple supply function, and let this be all the competitors to General Motors. So Ford, Chrysler, Nash, Hudson, Packard, everyone. Okay, so the inverse demand function is equal to price. Price is equal to 100 minus the quantity in the market. So the market quantity that's available is the quantity that's supplied by the leader firm, and the quantity supplied by all the competitor firms, the price taker firms. So what we have then is, so we rearrange this, right? So I substituted in the supply function from the competitive firms, rearrange, and now I get a residual demand curve for the leader firm. So this is the market in which the leader firm can act as a monopolist. So what we would do is we would multiply this residual inverse demand by the leader's quantity to get the leader's total revenue, differentiate with respect to the leader's output to get the leader's marginal revenue. We set it equal to the leader's marginal cost, and we get the quantity that the leader would produce and the price that they would announce. So when the leader firm announces the price of 30, that price gets put into the other firms, the follower firms or competitive firms, supply function, and we can get the quantity that's produced by the competitor firms. So I wanted to illustrate this for you graphically. We start with market demand, and then when we subtract off the quantity that the follower firms would produce, or the competitive firms, we're left with the residual demand. So as the leader firm announces a higher price, the competitive firms are able to take more and more of the market. Right? So you remember, the leader firm became the leader firm because they were larger and had had better cost structure. So when the leader firm announces a very low price, they are able to capture more of the market. As they raise the price they announce, they gradually cede market share to their competitor firms. Now remember, within this residual demand curve, the leader firm is able to act as a monopolist. So they set their marginal revenue equal to their marginal cost. That determines the quantity that the leader firm produces and the price that they announce. So they announce a price of 30. The competitive firms see that price of 30 and respond accordingly. And then we get the market outcome. Okay. Finally, we have a Bertrand duopoly, and that's where both firms choose the price simultaneously. So if each firm is announcing the price and they don't know what it is that their competitor is going to announce, we get basically what amounts to competitive firm behavior. And the reason why is that customers will always purchase from the lower priced firm. And equilibrium is for each firm to engage in marginal cost pricing. So think about if there were tamale food trucks in Waco, and they're not allowed to communicate with each other. Each of them sets their price on a daily basis. And of course, all of you are going to communicate, you're going to text each other and tell one another who has the lower priced tamales, right? So basically, I claim that each food truck has an incentive to engage in marginal cost pricing. We could do a variant proof to illustrate why this would be true. So suppose not, right? If we suppose not, what if one firm announced a price just a little bit higher than marginal cost, and the other firm announced a price equal to marginal cost? What would happen then is the firm that announced marginal cost pricing is going to take the whole market. So, so basically, by announcing a price above marginal cost, because customers communicate with one another, text one another, all the customers go to the lower priced firm. It makes no sense to charge less than marginal cost, because then the firm will be losing money each tamale that they produce. Right? They're not even covering manufacturing or baking costs. So I claim that the equilibrium or the equilibrium strategy is to announce marginal cost pricing. So in Professor Bergstrom's intermediate micro workbook, we were introduced to the dueling duopolists Carl and Simon. So they face a demand function for pumpkins, and there's a price. Suppose that each farmer has constant marginal cost of $1.50 for each pumpkin produces. And if Carl believes Simon is going to produce Q sub S pumpkins, we need Carl's reaction function. So remember, of course, to get Carl's reaction function, we revenue equal to Carl's marginal cost and solve for Carl's output. So to do that, we'll take the market demand curve and invert it to get inverse demand. So in the second line, I have inverse demand as a function of quantity together. We know that the market quantity of pumpkins is the sum of what Carl produces plus what Simon produces. So then we get that expanded inverse demand function on the third line. Now, if I multiply that inverse demand function by the quantity Carl produces, I get Carl's total revenue. I can differentiate with respect to Carl's total revenue to get Carl's marginal revenue, and then I set that equal to marginal cost, which is $1.50, and setting Carl's marginal revenue equal to Carl's marginal cost defines Carl's output. So Carl's output on the bottom line there is Carl's reaction function. It shows the quantity of pumpkins that Carl raises as a reaction to what he thinks Simon is going to do. Grinch and Grubb go into the wine business, and they have an inverse demand function. The thing that's a little bit different about this quiz problem and why I wanted to walk you through it is that Grinch and Grubb have different marginal costs. So Grinch is the lower cost producer at a marginal cost of 30, and Grubb's marginal costs are 45. And we need Grinch's output in equilibrium. So to do that, we need to get both Grinch's reaction function and Grubb's reaction function and substitute one into the other. Okay, so for Grinch, we have the demand. I didn't show this step, but of course the next step would be to get Grinch's total revenue and then differentiate to get Grinch's marginal revenue. We set Grinch's marginal revenue equal to Grinch's marginal cost, and that gives me Grinch's reaction function. So this is how Grinch reacts to what he thinks Grubb is going to produce. And we have to do the same thing for Grubb. Take the inverse demand function, total revenue, marginal revenue, set Grubb's marginal revenue equal to Grubb's marginal cost, which defines Grubb's output. which is his reaction function. Now, to state this very carefully, I want you to notice that Grinch's and Grubb's reaction functions are different. They're different because Grinch and Grubb had different cost structures. So to solve for equilibrium in this marketplace, we substitute one reaction function into the other. And what I've done here is I've substituted Grubb's reaction function into Grinch's reaction function. Although you could do the other. It doesn't make any difference, of course. But then I grind through the algebra and I get an output level for Grinch and an output level for Grubb. Now you remember Grinch was the lower cost producer, so since he's the lower cost, he's able to produce more than Grubb in equilibrium. Finally, market for bean sprouts, and we have a Stackelberg leader and a Stackelberg follower. So you recall with the Stackelberg marketplace, both firms are determining the quantity to produce, but the leader firm gets to move first. And then the follower responds to what the leader announces or does. So total output by the two firms, remember we have to solve this by backwards. So we have to solve for the reaction function of the follower firm. We insert that into the inverse demand function for the leader, and then we can solve for the leader's output and then the follower's output. So to do that, we have first the follower's problem. So we have inverse demand, total revenue for the follower firm, which I don't show, but you understand what it would be. I differentiate to get the marginal revenue of the follower firm, set follower's marginal revenue to the follower's marginal cost, follower's reaction function, what the leader produces. The leader firm, you recall, we take the inverse demand function, and the leader, of course, understands how it is the follower firm is going to respond to their announcement. So we substitute the follower firm's reaction function into the leader's inverse demand curve. And we get a simplified inverse demand curve for the leader that's a function of the leader's announced output only. And we have total revenue for the leader, marginal revenue for the leader, set that equal to marginal cost. And the leader firm now is going to produce 250 units of output. So we can put that 250 units of output into the follower's reaction function, and we see the follower is going to produce 125. Some of those is the total industry output, which is going to be 375, which would be the answer to this problem. So that does it for Chapter 28, Oligopoly.